Thank you. My name is Tang, and this is Yihan and Sharu. We are Sheikah folks. So yeah, let's get started. So the problem we are trying to solve is to really reduce the communication barriers for people in the daily life. For example, let's say if you're traveling into a foreign country, you don't speak the same language, that will be a big challenge. Or even though like it's like sometimes you go to a place that you really need that kind of local information that you don't have. For example, you're here in the San Jose Convention Center attending the Open OCP Summit, and you want to know who is coming, who is doing the talk, and everything. It's a little bit, work to do a Google search research, but instead we are developing a easy, simple user interface, which is like a chat message box, and then that's what we do. And language, I would say, like in general, like language itself is geographically distributed. Like every different place has a different, accents and dialects. That's what we are trying to do. Also, is like really has the local people using the local information and serving for providing the service. So in contrast to, let's say, you're using a ChatGPT, that you or like some other like cloud-based service, we focus on the in-person and on-site user experience, so you don't have to be distracted by the online stuff. The idea behind that is simple, straightforward. That the language, it has a positive correlation with the location and time. Like I said, like here today, I'm pitching off the open API AI related applications. The likelihood that the language I'm using increases by giving a little bit more context, like I'm here and right now. So that improves the usefulness, accuracy, and relevance of the chat. About Sheikah Tower, we are inspired by a Nintendo game. Like the name of the game is Zelda, and inside the game, the hero Link using kind of like a iPad, we call like Sheikah Slate, connecting to a tower that is nearby. The tower is not like serving like just like cellular tower to the internet access, but also has an edge server, like things like you can store or cache some local database, and had some sort of a little bit of computation resource that we can leverage for. We are building the Sheikah Tower, which is essentially the local AI virtual assistant applications. The data is provided by the local service providers. Like today is like event hosts that can provide the schedules of events uploaded to this platform, so the people nearby or people attending to this event can easily access to. How do we scale is like we are hoping for collaborate with the mobile network operators. They are like the operators like you like buy the 5G service or 6G service later on in the future. Like you want to buy an AI service, like you want to have a local service that is really relevant and useful for you. So the implementation of this, we have basically three parts. The app side, we developed the user interface app that is the chat box that user type in the text and image or audio files uploaded to the MEC server that is hosted on the edge server that is having the vector database. The useful information, and then the data is transmitting we do the layer of wrapping that we query the customer database and add it to the user input, connect them together, and send into the cloud side, which is the large language model, and giving a response. I think I will hand over to Yi for more information.
Yeah, so what it actually looks like in our UI. We are right now at San Jose downtown. So in this area, under the same zone ID and cell ID, all the available service provider will pop up. So for example, this Egyptian museum and the current OCP summit. And with each service provider, we have the database. So those two pictures are examples of when we're actually chatting with our assistant, what they will give us. In the first one, please ignore the found database. That's just for demo purposes. After I say hi, they actually find out, oh, now it's morning, now we're at the OCP, so maybe it's time for breakfast and registration, right? And another example is when I look for someone, I found so many great developer, but I forgot his family name. And this can easily help us identify who was the person I talked to and where and when to find this Andy. Another example is you can do really good context-aware search within incomplete input. For example, Sonic. When I look it up in search engine and other large language model, it told me it's a hedgehog from a video game, which is very famous, very cute. But under this context, you actually find the right concept for Sonic. Again, tell me where I can attend more Sonic workshop in the future. We can also take a multiple format, like image, and this is another demo for Egyptian Museum one. Given the time limit, I'll hand over to Sharu.
Okay, thanks, Yi. Let me summarize the benefit and beneficial of our solution. Three takeaways. First is the super user experience. As we can see, since we have a localized database provided by service provider like the museum event host, we can gain a lot of local context. Okay, I'll be really quick. And then the second benefit is that the secure and privacy, the private data like photo and some user profile, they live in the edge server. They won't be sent to cloud. And the last, we optimized using the edge server because it's local. So the server is very close to our users, so we can really make a very low latency search queries. That would be the three main takeaway, main benefit of our solutions. Thank you. Any questions?
Anyone ask them? Already asked all of my questions.
Very impressive. So is it the main idea, the local ChatGPT?
Yes, the main benefit is the service provider, like the event host, the OCP Summit event host. You can upload your own local database. It's a federated database. And we are a platform to host that local knowledge. So compared to the bare-bone ChatGPT, we will provide actual information, give the agent some local context, so they will provide a superior user experience.
Yes.
Yeah. So you mentioned about the family name for the person I met and I forgot their name. So that is image recognition, right? And that is built in?
I can take it. So it's like, say, I only remember the first name of a speaker like David, but I think he's working on, say, in Meta, and I cannot remember the exact name. So I can ask the AI agent, who is this speaker? And the AI agent will find all the information and the event that the speaker will give.
So it's context plus
yes,
half information, not like image recognition. Okay, thank you.
We put this database last night, so it's very easy to implement. But the family name you mentioned is actually public information. It's just a quick demonstration how we can leverage those databases for the future. Like, for example, if we work with a museum, we will work with them to build their database. They own the data. We don't own the data. We just provide the solution.
Okay. Thank you, guys. Team 1, thank you. Big applause. Great job.